rise over run, yeah. So we need to find the gradient. That's one thing on this line that we need to find, and also we need to know the y-axis intercept. For what we're doing, that's what we need. So actually, in a graph, all we need to do is see that. All right, but that doesn't mean that that's the only information we're being given. So, for instance, on these ones, can we see rise over run? Can we see the gradient of the lines? Yes. Yeah, we can. What do you need to find a gradient? Yeah, and how do you get to that? What do you need to know to be able to get to that? Simple answer, it's not a hard answer. Just to do that, you must know 2 points, yeah? You have to be able to find 2 points, to be able to identify the 2 points. And that's something that we're going to move on to, because what I would like you to be able to do is to be able to find the gradient of a line without even seeing the line. I just give you 2 coordinates, right? And you can even then find the equation of the line. Right. So this information, we've got the gradient, we know 2 points. Do we have the y-intercept? Yeah, so that's all we need. These ones, well, this one, would it make any difference to you if I got rid of all of this kind of information? Oh, come on, draw it. Going to do it in a sec. So if I only gave you that, would you still be able to find the equation of that line? Yes. Yeah. All right. So it's just about having more information than is needed. That's all. Because these lines, because they're not for a given situation, go on forever, don't they? They don't stop. When we apply them to an actual situation, they might have limits. Excuse me. So, for instance, I've said we don't need any of that information. What about this one? Is there anything that I could just cover over and not need? Yeah? So if I were to cover over that, have we still got all the information we need? Yeah? This one, is there anything I can cover over? Sure? Top half, isn't it? Actually, although we normally show the top half, I don't actually need that. Could I still find the equation of the line from that information? Yeah? Right, what about this one? What is there anything I could cover over? The top right, I could do all of that side gone, and I could get rid of that, yeah? Is that all the information I need? So if you think about it, what you need to do is, even though there's a lot of information there, you've got all 4 quadrants as we call it, you just need to identify the information that you need. Make sense? Okay, so everyone, apart from the 2 here, finished off all the answers, yeah? Everyone did. Pardon?
I remember last.
Why not? Didn't get it. What was different about it than the other 2? Well, should we go through all the answers now then? You just tell me what the answers are. So we've already done. So we did first 6. So on the first page, just one at a time. Nick, do you want to give me this one? A half plus 4, like that. That's a common thing to write and you would get no marks. What do we miss? Half x. You have to have the x. It's a half of x. And we need to talk about that as well. This one? Y equals 2x plus 2. Good. Yeah.
Is it okay if you write it like the opposite way?
It's fine. I noticed that's what you were doing. Yeah. Last lesson, but it is fine. All right. What you would do you remember though when we were writing equations, the standard way to write an equation was to always put the x's first. So do you remember we did kind of, if it was x squared, we would put x squared first, then the x, then the constant. That's the normal way to write it. So the way everyone's expecting to see it is if I've got an x, it comes first. The only difference is in this one, do you remember when we've got a negative x to start with, right? We put that the other way round because of the negative sign could be misplaced. So just in case you don't know what I'm talking about, Daniel has the tendency to write it like that. Is that fine?
Yes.
Yeah. Okay, absolutely fine. It doesn't mean anything different. It's just normally we would write it 2x plus 2. This one is slightly different because we would write negative x plus 8 is correct, but we generally put the negative second. All right. These ones then. Y equals negative x plus 7 or
7
minus x. Someone else?
6 minus 2x.
Y equals 6 minus 2x. Yeah? Or negative 2x plus 6.
Y equals 8
Is it y equals 8 minus 2x? Okay, someone different this time? Y equals 5 minus 2x. Tally, do I do this? 9 minus 3x. Good. We've done this one. 4 minus a half x. Okay. Almost, but not quite. What did you miss? The negative. So negative 4x plus 8, or that could be 8 minus 4x. It's fine. Okay. Y equals the last one on the second sheet.
9.
Nope, it's not half. No. Two x, yeah. Okay. These ones then, got rid of some of them now, but the third sheet. Go on. Yeah. Yeah.
Y equals 2x minus 4.
Yeah. Nick.
Y equals 2 plus 2.
It's not no, sorry. You're missing x's.
Because 8 is the y.
Yeah. So what's the answer?
8 plus 8.
So y equals 4x plus 8 it should be, yeah. So again, I think what happens is people get confused with the fact that it's all on the negative side. Alright, but just take the information that you know and use that. Next one in line, 2x minus 4. This one. Negative x minus 4. Now, is there any point in rearranging this one? Yeah. There is one thing that we can do though, and we could rewrite that. Sometimes people would do this. Negative brackets x plus 4. Do you understand why I could do that?
Because everything in it is a negative. The negative multiplies the x and multiplies the positive sign, making it a negative.
Exactly. Yeah. So that is actually an example of what we've done before, which is factorising. Right? And actually the negative is not just a negative, it's a negative 1. Okay? This one? It's not y equals 2x. No. Good. Y equals 1/2 of x plus 1. Yeah. What's slightly more difficult about that one? Yeah, they've not put the fact that that's a 1. All right, we do know it is because it goes through like this, and we can see it must go through halfway. But yeah, it's looking at the behaviour, the patterns, and you can come to the conclusion that it must go through 1. This one next. Y equals negative 1/2. It's not negative 1/2. It is negative. Okay. That's what he said.
Negative 1.
Is it a negative 2?
Well, negative 1/2 or negative 1/2 is the same thing. It's not a half. Negative 2 over 3. Yes. Negative 2 over 3. Rise over run. Right? So we've got, if I pick 2 points, okay, the rise is dropping 2, so it's negative 2, and the run is, excuse me, 3. So in this case, we just have to write it like that, rise over run, and just leave it. We can't simplify it, right? So it's negative 2/3 x plus 4, which we could also write as 4 minus, okay? And finally,
Y,
go on.
y equals
Negative 4x minus 4.
You think so? So let's just check. So we've got a point there, and the next point is down there. So it is a drop of, that goes through minus 4, but the rise and run, so the drop is 4, negative 4, and across 1, so it is negative 4, and it crosses negative 4. How could I rewrite that using the same thing I did before? Yeah.
Negative bracket 4x plus 4.
Yeah, that would be one way. Another way to do it, just to show you, is to write it as negative 4x plus 1. We don't have to. I'm just showing you that's another, all these things that you have learned how to do, we can use them in that way. Okay. How'd you get on? Did you get them all right? Those people that watched the video, see them, does it make sense? Yeah, you'll be able to.
On the last page, I forgot to write x.
Do you know what? That's a very, very common, but it's a weird one, because I don't like calling errors silly, because there's a reason why you didn't put the x. And I would say the reason why you didn't put the x is because you don't appreciate what the x is doing. And we need to go back and talk about what this equation actually means. Right? We're not going to do it yet, but again, let's just recap. What do straight lines, the graphs, show? Constant change. Jade's in there like that now. Right? A constant change. Could you expand on what we mean by constant change? Pardon? I'm thinking of a little bit more of a sentence rather than just another way of saying constant change. Yeah.
Always increasing or always decreasing.
What is always increasing or decreasing? I'm thinking about, we're talking x's and y's here, or the two variables, or say it again. Sorry. Well, you're not far off. So a constant change. Anyone want to find again? Go on.
As it as a line.
So forget the line, just use X's and Y's.
As y goes up, x stays equal to.
No, it doesn't actually. So actually what it is, do you remember we talked right at the beginning about taps, faucets being opened and water coming out, yeah? What does a steeper line mean? So what does that mean in terms of our water? You're right, what does it mean? If the changes is happening at a faster rate, if it's a steeper line, the water is coming out the tap faster. You've opened the tap more. So the line, the amount of water in your tank is going up quicker, yeah? What is the gradient again then? But in the actual situation. So what would the change in y divided by the change in x be? What would y be?
Time.
Yeah, time and... Yeah. So if I were to draw a graph, this time I only need it like that, yeah? Because we're talking time and water. But what if I did my line like this? Okay. So I said to you, this axis would be the what axis? If it's,
Y-axis.
it is the y-axis when we have nothing to put in it. What about the water? Okay. So let's say the amount of water. So we could say that as the height of the water in a tank. So let's say we have a tank of water, yeah? Here's the tank. I've got a tap and the water's coming in, right? So if we look at the amount of water in that tank, that's going to go up, yeah, as the tap. So the higher, so this tank is filling up like that. What happens if I have a wider, shallower tank like that? What happens to the height of the water? What will the graph look like? Will it be, sorry.
No, it would be less steep.
Will it go like this?
No,
Or will it go like that?
like that.
Why? Yeah, because the water has to cover a larger space and surface area before it can start going higher. Whereas the narrower tank, it just goes, just like you filling up your water bottle. You notice we said bigger bottle, as it gets to narrower at the top, suddenly it goes, that's not even changing the tap. So let's just talk about this just to recap. This would then be time, yeah, in seconds or minutes or whatever you want it to be. So what would our gradient be? So the change in y is actually the change in... No. The water height. So change in height of the water. And this would be the change in time. So actually, if we would look at the units, we've got something called centimetres per second or minute or whatever. So this would be called a rate. It would be the rate of change of height with time. So with a steeper line, it means the rate of change of the height of the water, as Safia said, is increased. So that's what we've been working on. All right. Now, just a quick question then. So that's the gradient. What about this value here, where it crosses the y-axis? Good. Spot on. All right. This is at time 0, and this is how much water was in there to start with before we started filling it up, yeah? Which should make sense to you guys because, you know, you've all got water tanks at the bottom of your houses or apartment blocks or whatever, and, you know, when you have to fill it up with water, there will already be some in there, yeah? And the truck comes and they put a load of water in using their tap, so there will be some already in there. So That's what we're looking at. So we need to remember all that when we're talking gradient and things. What does a negative gradient suggest? That it's decreasing. So final question on this before we move on to the rest of the questions. What does it mean if I forget the x in my equation? In this case. There's no change in time. So this one, let's just say I have an equation and I say it's y equals 2x plus 5. Could you interpret that for me in terms of the water? Use whatever units you like. So what is y again? The height of the water. What's x? So interpret that for me. What does that equation tell me using time and height of water? Nick wants to give it a go, I can see. Go for it. Be the initiator that everyone else builds from. So actually every second, probably, as x increases by 1, you're right, the water increases by 2 centimetres, yeah? What does the plus 5 tell me? You already had 5 centimetres, right? Spot on. To work out the height of the water, I know that I take the time, x, and multiply it by 2 because the water is going up 2 centimetres every second or minute or whatever you choose. And the plus 5 means there was already 5 centimetres in there. Spot on. Good. All right. What would it mean if I did this? So what would that actually tell me? It does tell me something.
Oh, that y equals 7.
Y equals 7. So what does that mean?
The height of the water is 7 centimeters.
And there is no change. Exactly. It's just at 7 centimetres and there's no... So is it really important that we have to have the x? Do you understand if you write it without the x in a test and I mark you incorrect, you know why? Yeah, because you changed the meaning completely. Actually, this then leads us, do you know what y equals 7 would look like as a graph? In what way? Yeah.
Yeah, there would be a line.
There would be a line, actually. It won't be very short. It will go on forever.
It would go 7 and then just go straight.
Yeah, so think about it. It would just do that, wouldn't it? It would tell me that the water height never changes. Time never stops, so it won't be a single point. But so this is something we need to talk about, the equations of horizontal lines. And it's when we have a constant. So there is no change, we just have a constant. But we do need to eventually work on that. Okay, we'll come back to that and we'll make some proper notes at the time. But I just wanted to keep that in mind. So let's go on to these next questions. All right. You know how to find the slope of that line. Just interested. So it says, here you go. We've got some equations now. What are the slopes of those lines? So I'm looking at questions 5, 6, 7 and 8. Don't start 1, 2, 3, 4 yet. I'm looking at 5, 6, 7 and 8. Just going to do one with you. Do you know, I know you now know how to do the slopes of these. It looks different, but they've given you 2 points to use. You don't have to use them. You can work out those. Just recapping what we did before. But what about these ones? So there is no graph, but you have the equation. So what is the slope of the line if I look at the equation? So this one, m. Remember I said m is for gradient. Because remember we looked at, and it's on the top of your sheet, it's in the form mx plus c. And this is called gradient and intercept form. And you know why now, don't you? because that's the gradient and that's the intercept. So what's the gradient of this one? It's really easy. Negative 5 over 4. Done. That's all we have to do. So I'm going to let you finish those off, but I'm going to do this next one with you, number 9. So can we do this one together? Ignore the rest of those, you can come back to it. Let's talk about number 9 together. I would like to know, how do you find the slope of the line when you're only given 2 points and you don't have the line? Not y squared?
Y2 minus y.
Yeah, so remember m is y2 minus y1 divided by x2. So that would be, we can label it x1, y1, x2, y2. So we then do 7 subtract negative 6 divided by negative 11 subtract 17. Now, just one point here. It doesn't actually matter which way round you do the x1 and x2, as long as you're consistent. So if you call this one x1, this one has to be y1. If you call this one x2, this one has to be x2. So I could flip this around if I like. Negative 6 subtract 7. But I can't then leave this one the same. So I can't do that. All right? Does that make sense?
Yeah.
I can do negative 6 subtract 7 and then do 17 subtract negative 11. You will find if you do those, you get the same answer. All right? But you can't swap one and not swap the other. So it is worth just saying x1, y1, x2, label it on your points. Right, so the answer to this one would be 7 plus 6 makes 13 divided by negative 28. Where does the negative normally go? On the top one. So can we simplify negative 13? No, so I would just write it as negative 13 over 28. All right? Doesn't matter that those numbers are a bit funny compared to what you're used to seeing. That's just how it is. In terms of water in the faucet, what would that gradient mean? Please don't put your head down now and try and do the next one. I've asked you a very important question. What does that negative 13 divided by 28 mean in terms of water tank?
The water in the tank decreases
Yeah,
over time
be more specific.
as the
Be with the numbers. So the water decreases by
13 centimeters
for every
28 seconds.
28 seconds, yeah? You see what that means, yeah? The water decreases 13 centimetres, that's why I've got negative 13, every 28 seconds. Perfectly reasonable thing to say, right? Okay. You can finish off those other ones then. And then we've already talked parallel and perpendicular lines, so you should be able to get on with the next one. Right, so back to these first ones. What's the slope of this?
2.
So I've got a point, well actually I can go, a point there is at negative 1, and it goes down to 2, 3, 4, negative 5. So my run is
2.
4. And my rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's m is 9 divided by 4.
Wait, what? Wait, that's
1, 2, 3, 4, 5, 6, 7, 8.
How did I get 8 over?
I don't know. Right, next one. So this one would be a negative, and then we've got 1, 2, 3, 4, 5, 6, 7. So negative 7 divided by, and then it's 1, 2, 3, 5, 6. Negative 7 over. Okay?
Wow.
So these ones are just a little bit different numbers. They're not simplified in any way. Yeah? Doing this one first. This one, we've got the rises 1, 2, and 3. And it's 1, 2, 3, 4. So 3 over 4. This one is minus 1 over 1, 2, 3, 4. Minus 1 over 4. Okay? Right, so just to prep you then, we'll go through these points once again, and we will also talk about, these are the important ones, parallel and perpendicular lines. Thanks, Safia, for paying attention and staring off into space.